Assalamu alaikum. In 1969 was a victorious year for the humankind. In this particular year, Apollo mission was launched to the moon and man was landed to the moon for the first time. At that particular year, the scientists have collected some samples of the rocks from the moon and brought them back to the Earth. After looking at them and analyzing them in the lab, they found that the rocks of the moon were similar to those found on the deep earth. But something different that they have also discovered, although the earth and the moon was the same, yet the soil of the moon was completely different than the soil of the earth. Now, if we think about it, why is that? Why does that things happen? And what is the reason behind it? After spending some time, the scientists have found that the soil of the earth is subjected to different factors that lead to make it a dynamic natural body, evolving over the time. The gases, which is actually in the atmosphere, the biological life and water, all of these things have led to evolution of the soil of the earth than the soil of the moon, where all of these factors does not exist in the moon. In today's lecture, we're gonna learn how the soil is formed. And basically, we're gonna go to the main story, how the soil is formed from the rocks. If you looked at this picture, you would find that here you have rocks, which we call barren materials now, like the parents of the soil, like the mother and dad. In the soil is formed above the rocks. How the soil formed, what factors, what is the process describing this formation? It will be things that we will explore in this lecture. So without further ado, let's begin. Now, if we want to understand the formation of soil from the barren material, then it is also a very important thing to understand the classification of the barren material. I mean, the classification of the rocks. Basically, we have three different types of rocks. We have igneous rocks, sedimentary rocks, and metamorphic rocks. Now, if you look at the igneous rock, the igneous rock are basically formed as follow, where you have a magma, which is usually very hot and like dissolved minerals, primary minerals. When these actually minerals are erupted, or when the magma is erupted to the surface, it's exposed to the air and it starts to cool down. And this is what actually forms for us the igneous rocks. Example of the igneous rocks like granite, diorite, basalt. And there are actually other rocks like quartz, feldspar, biotite, augite. Now, if we look at the second type of the rocks, we have the sedimentary rocks. Now, what basically the sedimentary rocks and how the sedimentary rocks are formed. If you have a soil or if you have rocks that are weathered and eroded, then the particles will be actually carried down by water to somewhere where actually they will be deposited. Now, what will happen when these sediments are deposited in a place, then it keeps actually building up. And because of the pressure, it's actually getting compacted. When it's compacted, it forms different layers, again, with the cementing agents, like some of the let's say like salts or other minerals that exist, they actually form a cementing agent which actually grows the sediments together, and this is actually what forms for us sediment rocks. Sediment rocks, because they are formed from sediments. That's why they are actually a result from deposition and re-cementation of weathered products, like igneous rocks or sedimentary rocks or metamorphic rocks. So basically, whatever type of rocks you have, when it's weathered and re-cemented, it forms sedimentary rock. Example of these can be sandstone, shale, and limestone. And usually these rocks are actually like composed of primary or secondary minerals. If we look at the third type of the rocks, we have the metamorphic rock. Now, the metamorphic rock are actually formed through a process called metamorphism, which describe a change from one form of rock to another. It basically, when you have pressure and you have heat, because if you go down into the earth, closer to the core, the heat increases. So when you have pressure from the surface rocks and the heat, basically they lead to the formation of the metamorphic rocks. An example of this are actually the marble, quartz, and slate, gneiss, and schist. So basically the key component here that these type of rocks are formed under extreme pressure and temperature. And these are some pictures of the examples of the metamorphic rocks. Now, something very important that I want you to keep in mind that there is something called rock cycle, which means that igneous rock, when they are actually weathered and recemented, they will form sedimentary rocks. The sedimentary rocks, when they are also like, when, for example, the sedimentary rocks can also form metamorphic rocks if they are actually subjected to high temperature and pressure. And and also like the vice versa, where you can get, and also actually the same cycle would continue to get the igneous rock. I have posted a video for you in the model, watch it, and this video will describe to you in details the rock cycle. Something very important that I want you guys to keep in mind that if we analyze the crust of the earth and look at the elements that actually dominate, you will find that oxygen, silicon, and aluminum are the most dominant elements that exist in the earth crust. Now, I'm expecting from you to know that if the soil comes from the rock, then probably the soil will inherit these characteristics. So we expect that the soil also to have a most abundant elements like this. So we expect that the soil will have lots of oxygen, silicon, and aluminum almost in the same range, because the children can inherit from their parents, and the same things that the soil will inherit from its parents from the rocks. Here, I'm illustrating for you something very important. This is actually a picture showing you a grave mark. One is made from granite and another one is made of marble. The pictures have been taken at the same time from the same place. So it is subjected at the same weather condition and everything is the same. The only difference here is actually the type of rock which the grave mark is made of, and the other things, the year of sculpturing of this rock, of this grave mark. So this one was, the writing on it was sculptured in 1798, and this one was sculptured earlier, in like recent than this one. So this one is older. Now you would observe that the marks on the new one, the marble, already disappeared. While in this one, still the marks are very sharp and you can clearly read the details here. Why these things happen? Think for a moment about it. Pause the video, and once you get an idea, you can continue and listen to the answer. Well, basically, this is because the type of the rocks. Now, the granite has lots of primary minerals, which basically are resistant for weathering. So we can say that the different types of rock would have a different ability to resist the weathering condition. So the granite is more resistant than the marble. Now, Why does that things happen? We have to look at the sum of the details. Now, this table shows you different things. Shows you the, first of all, primary minerals at this side, and at this side you have secondary minerals. Then if you look here, it shows you that if you go down, the resistance of whether secondary minerals or primary minerals would be reduced. Now, something very important to know that during weathering, the minerals can be converted from primary to secondary. And when they convert it to secondary minerals, they will become more stable. It means there's no further change of the secondary minerals, meaning that the secondary mineral will not undergo change to convert them into like tertiary minerals or something like that. It's the end product from primary to secondary. Now, the other point that if you notice that the minerals which are actually exist at the top here are more resistant. It means if you have a rock that have minerals from these, from the top parts here, then it becomes more resistant to weathering than if you have rocks which actually composed from some of these minerals at the bottom. The same things for the secondary minerals. When the primary minerals are converted to secondary minerals, then some of the types of the secondary minerals also would be more resistant than the others. Geothite, hematite, gypsite, these are secondary minerals which are more resistant to weathering than calcite and gypsum. And the same things for primary minerals. If you have minerals that are, if you have a rock that is actually composed of quartz, then it will be more resistant than a rock that is actually made of olivine. Now, how the soil is formed from the rock. There is actually a process called weathering. And the weathering in a simple way, it's actually the breaking down of the rocks into loose material, small fragments. And it actually can happen due to two types of weathering, physical and chemical weathering. Now, when the rocks are broken into smaller pieces into the soil, then if this soil or these smaller pieces subjected to different actions of physical and chemical weathering, it can also undergo changes. And these changes are called actually soil development. So the changes from one state to another is actually a development. It's also, we can reach a maturity of the soil. With time, with these changes, then the soil can develop. If we look at the weathering from its concept again, it's breaking the rocks down into smaller in size. So there will be a decrease in the size. Also, there are some changes that happen internally because of water. So some of the minerals might be changed from primary to secondary, or some of the minerals might be dissolved and released. And this is actually what we call the chemical weathering. So if we put the difference between physical and chemical weathering in a simple way, we can say that the physical weathering is only the change of the size, breaking down the rocks apart and breaking it down into smaller pieces without it changing its chemical properties. Whereas the chemical weathering is basically an alteration of the chemical properties of the rocks. That's why you can find changes from one type mineral to another, from primary to secondary, or you can find a dissolution, removal, or addition of minerals into the soil. Now, if I want to give you more details about physical weathering and chemical weathering, then you can find that in the physical weathering, it's a disintegration, which is basically broken down into pieces. And then it's also a decrease in the size. It's also no changes in the chemical composition, and it basically caused by the grinding action. Like when you grind something, It's grinding action of wind and water. Whereas the chemical weathering is basically a decomposition. It is a change in the chemical properties. Some of the soluble materials might be released. Some of the minerals, because of the chemical reaction, might be formed, new minerals, and some of the minerals might dissolve in the water. And this is actually mainly happened due to the water, due to water. If we look at more details about the physical weathering, then we can find that the physical weathering can happen by, for example, the action of temperature. And we have here the expansion and contraction. Now, if we look at the picture here, you would find that during the morning, when the temperature increases, then there will happen, what kind of things would happen? Expansion of the rocks would happen. Now, what would happen during the night when the temperature cooled down? Contraction happened. And the next day, again, you will have expansion and contraction. Because of this action, then the rocks can be broken down into smaller pieces. And here is another illustration. So expansion during the morning, when the temperature goes down during the night, then contraction happen. And because of the expansion and contraction, the rocks would be peeled away. Another process called exfoliation. Exfoliation is the same things when you, for example, do an exfoliation for your body, by which what will happen that you will actually remove the things from the surface. So this is, for example, an example of exfoliation, and this is what we call something looks like cabbage, or it looks like onion peeling. It looks like onion peeling of the rocks. Another example of the physical weathering is actually the abrasion. Abrasion by water, ice, and winds. In a simple way, as water flows over the surface, it can, for example, the wadi, it can carry with it some of the rocks. Now, as these rocks move, they actually hit themselves. And due to this hitting, and due to the hitting with the surface, the rocks can be broken down into smaller pieces. So water has an erosive power. Wind also can do the same things, and I would give you more details. When the wind blows, they also take with it these sand particles. As these sand particles hits the surface, they can also cause grinding of the rocks, especially if you have a sedimentary rocks. And this is an example of the exfoliation, which basically is actually due to temperature, due to the differences in the temperature. The temperature of the outside of the air is hot during the morning, whereas in the rocks, a little bit different. Then during the night, the temperature of the air will be cooler than what happens to the rock. And due to these differences, then the surface of the rock might peel, looks like the onion peeling or the cabbage peeling. Another example of the physical weathering is basically the plant and animals. This is also can consider as biological weathering because it's the action of the biological life. For example, when you have the roots of the plants, as the roots of the plants grow, it gets through the cracks in the rocks. And as they grow, the roots becomes larger and larger. As the plant grows, the roots becomes larger and larger. And this is actually push the rocks apart until they become broken. There are other things like what we call prowling animals. And the prowling animals like the rabbits, like the rats, and like many others, when they create some it's like they burrow into the soil and into the rocks and they create holes. And because of this, during this process, they actually help to break down the rocks, especially if you have a sedimentary rock. It's easier. Remember, again, different types of rock might have different ability to withstand the erosion power. And if you look at the sedimentary rocks, you would find them that they are actually weaker. They have less resistance to weathering than the, for example, the igneous rocks or some types of igneous rock. And here is an illustration on how the wind also can cause abrasion or can cause physical weathering. So as wind again blow, it actually carry with it some of the sand particles. And as these sand particles hits the surface of the rock, especially if we have a sediment rock, they actually hit it. And due to this hitting, abrasion happen and the actually breaking down of the rocks would happen. And this is the end result of the weathering. I think that's all about this lecture. So I hope that you enjoyed the concept. Read, watch the video several times and put down your notes, and I would be waiting for you in the discussion session. Till that time, take care. Goodbye.